Hello everyone, welcome to Gangs of PCM. This is Priyanshu and together we are going to solve all your physics related worries. This question we are going to discuss today is from JEE Mains exam held in January of 2020. This question is from chapter Waves, and to solve this question we need to know the concepts of Doppler Effect and relative velocity. Now let us solve the question. So question we can see that velocity of the sound is 350 meters per second. And if you look at the options, you can find that the velocity of the source and velocity of the source is much smaller than the velocity of sound. These are the velocity of tuning fork, and tuning fork is our source. So velocity of the source is much smaller as compared to velocity of sound. So this assumption will come handy while we are solving this question. So please remember this. Now let's solve the question. In question, what is the conditions? We have an observer which is stationary. Let's say V0 is the velocity of observer. So this would come out to be 0. We have two tuning forks. Let's say one is green, which is moving towards the observer, let's say with velocity Vs, and other is tuning fork blue, which is moving away from the observer, let's say with the same speed Vs. As it is given the question, both the tuning forks have same speed. So let's say this is your tuning fork 1 and this is your tuning fork 2. Both of these tuning forks have frequency nu naught. Let us say the frequency of the sound produced by these two tuning forks is nu naught, and nu naught is equals to, as you can see from the question, nu naught is equals to 1400 hertz. Now, when there is a relative motion between source and observer, if this is source, this is observer, there is a relative motion between them. In that case, the frequency heard by observer is not equal to the frequency produced by the source. So this is the frequency produced by the source and nu is the frequency heard by the observer. So these two frequencies are not equal. So a different frequency is heard by the observer, and that is known as your apparent frequency. This is known as your apparent frequency. From the formula of the Doppler effect, we get that formula as nu dash, or apparent frequency, is equals to original frequency produced by the sound, into v, velocity of the sound, plus v0, velocity of the observer, divided by v plus vs. This is the general formula for Doppler effect. In this formula, v0 is positive. That means your observer is moving towards source. This formula is only valid, or the plus sign would over here, when your observer is moving towards source. And here the plus sign would be on denominator. Vs would be positive when source is moving away from the observer. So in the case when source is moving away from the observer, what would happen? This would become negative. And the case when the source is moving towards observer, this Vs would become negative. So this is the general formula. Now let's talk about the first case. First case is these two. When the source is moving towards the observer and observer is stationary. So let's talk about case 1. Case 1 is what? Vs, source is moving towards the observer and the observer is stationary. V0 is equals to 0. This is our case 1. Okay, so from the formula of apparent frequency, let's say the first apparent frequency is nu1. Nu1 is equals to nu naught v plus v0 is 0 divided by, see, source is moving towards the observer, so we'll find this condition. So this would be v minus vs. Okay, let's take v as common, so we'll have from here nu naught v upon v into 1 upon 1 minus vs by v. Okay, let's take the numerator for that. Let's take this numerator, reciprocal for that. We'll have 1 minus vs by v minus 1. The power would be raised to minus 1. Now we know that, remember the assumption which we have taken, vs by v is much smaller than 1. Then we can apply binomial approximation for this part. So nu1 would be equals to nu naught 1 plus vs by v. Binomial approximation says what? 1 plus x to the power n is approximately equals to 1 plus nx if your x is much smaller than 1. So this condition is satisfied over here in this part. So we can apply binomial approximation. So from here we get the frequency of the or apparent frequency due to the first source. Now let's talk about the second case. What is the second case? In second case, again your observer is at rest, so velocity of observer is 0, and your source tuning fork is going away from the observer, going away from the observer. So if you look at the formula, let's say nu2 is the apparent frequency for the second case, is equals to nu naught v plus 0 divided by v plus vs. Since it is going away, you will have a positive sign over here. Now again we'll take v common from denominator. You will have what? Nu naught v divided by v into 1 divided by 1 plus vs by v. Again take the new denominator to the numerator, take the reciprocal, we'll get what? We'll have 1 plus vs by v to the power minus 1. Again this part is very small, or we can use binomial approximation for this part because vs by v is very small. Vs by v is very small. So we can say nu2 is equals to nu naught 1 minus vs by v. So this would be the frequency produced by or frequency heard by the observer due to the second tuning fork. Okay, so now we have two frequencies heard by the observer. The first frequency is due to the first tuning fork, which is nu naught 1 plus vs by v, and the second frequency is nu naught 1 minus vs by v. So when an observer hears two frequencies, he would experience something known as beats due to the difference in the frequencies of sound it has heard, and number of beats is equals to mod of difference of their frequencies, or difference of the frequency, it would be equal to number of beats. Now this is given to us in the question. Number of beats is how much? Number of beats is given as 2. Using these two formulas, let's put in number of the beats formula, and we can see what would be our answer. So we'll have, which one would be greater? New one would be greater. So we'll have nu naught 1 plus vs by v minus nu naught 1 minus vs by v is equals to 2. Let's take nu naught as common. So you'll have nu naught as common. 1 plus vs by v minus 1 plus vs by v is equals to 2. 1 and 1 will get cancelled, and you will have 2 vs by v is equals to 2. 2 and 2 would get cancelled. So from here we get vs as v by nu naught. And from the question we know that v is equals to what? 350 meters per second, and nu naught is how much? It is given as 1400 hertz. So let's solve this. We'll have 5 divided by, from 7 if we divide them, this would be 5 and this would be 20. This would be 1 by 4. So from here we get velocity of source as 1 by 4 meters per second. Let's look at the options. So from the option we can see that our first option is correct. Option A is correct. Okay, so we are done with the question. Thank you everyone.